Hey YouTube, what's going on? Quadratic functions, part 3, all types of transformation that we're going to consider right now. So this is the course, crash course, everything you need to know in order to succeed with quadratic functions. So by the way, actually today's Happy Valentine Day, so happy Valentine to everyone who's watching, who's currently watching right now, and to all my subscribers. Thank you guys for your support. I really appreciate for your efforts that you actually visited my channel, watching the video, and sharing the comments. I'm very pleased. Let's get started. So grab your pens, grab your notes, and let's do it. So we first going to consider basic parabola with equation y equals x squared. So in this case, as you remember, this is the standard equation, x squared plus bx and plus c. And in this case, what we particularly have is that a is simply 1 and b is 0, c is 0, okay? So that's why we have y equals x squared. However, today's purpose is to come from standard equation into the vertex form. That's this form is quite convenient in order to describe vertex position of the parabola. And this is the solely purpose to pick up quick the coordinates x and y for the vertex. Okay, so that's why for the parabola y equals x squared, for basic one, we can create the set of table or set of data in the table by picking up from the middle point, which is the vertex, and going to the right and going to the left symmetrically, because we know for that parabola the x vertex is simply equal 0, so that's why the equation of the line of the symmetry for this parabola is going to be this vertical line y-axis or x equals 0, okay? So that's why all the y values, so they will be the same for different symmetrical x values. So one is positive, another is negative. So that's why normally in order to plot using dataset or values for x, you can use the formula y equals x squared, calculate corresponding y values, and symmetrically put them around the vertex. So this is the vertex actually with the coordinates 0, 0. Okay, so that's how I drop those points. So this is the basic. One significant case, because the values are symmetrical, means no matter where you take in positive 1 or negative 1, you still have one single value for y. So indeed you have for 1 here and for negative 1 the same y value, and no matter which x points you take, x coordinates you take, you'll have the same y value, like for 2, and for negative 2 you still have the same y value. That means the property of the function which is even. So simply you can say that function is even if you put negative x, and you'll get still the same value as if you put like positive x inside, okay? So this is how the basic parabola looks like. We actually built it before, and now we're gonna do the first transformation that's called enlargement or scaling. So in this case, we have the coefficient a before x squared, and might be different. So for example, in this case, it's 0.5, so this fractional one, so we can rewrite as 1 over 2x squared. And here is the negative, so negative 2x squared. So where a coefficient actually is what stays before. Even if it's written in the form x squared over 2, you need to go to this form or to the decimal form so that you clearly understand what exactly stays before x squared, okay? So you need, in other words, you need to come to this type, ax squared, okay, so that you clearly see the coefficient a. So in this case, a is 1 over 2 or 0.5, and in this case, a is negative 2. For the same purpose, I want to see the values for given x. So that's why I can quickly drop the y values by just simply calculating. So 0.5x squared. For 0 we have 0. For 1x1 we have 0.5 or 1 over 2. So when we plug 2 for x, we have 2 squared is 4, and 4 times 1 over 2 is 2. So symmetrically, we'll have the same values, and you can also explain why, because we still have the same vertex. So vertex for this function, 0.5x squared, is 0, 0. So vertex point is not moving anywhere during the scaling. And here is the same story if we calculate the value. So the vertex is not moving anywhere, okay? It's still central values that you can see here. And symmetrically, all odd values for y will be set up on the right and on the left side from the symmetrical value. It's sort of like median, you know. In statistics, it's a high resemblance with the median. Okay, so let's calculate y values for the second function, negative 2x squared. Just simply what we can do actually, we can take the basic values and multiply by negative 2, because we already have values for x squared. Let's do it using the shortcut. So we'll get negative 2, negative 8. And here is the same. We'll have symmetrical value, negative 2 and negative 8. Okay, so we have both sets. And now let's see what's happening actually with y values. So here we see that the values is simply dropped by the factor 1 over 2. So as if we multiplying all the previous values for basic parabola by a factor 1 over 2. So that's why you simply have them. Here, it's simply the same as we multiplying by the factor negative 2. So that's why from 4 we get negative 8, from 1 we get negative 2. So what we can notice that simply the rule is the following. We're taking the basic parabola x squared and we multiplying by coefficient a all the values that we got for y. So that's why it looks like you're taking a multiplying by basic y values, and that's how you can get y of your functions. Okay, let's drop this parabola quick. So for example, 0.5x squared is simply those are the points, and when 2x is also 2, so this is actually their parabola y equals 1 over 2x squared. So what we noticed that, so here's symmetrically, we can also reflect. Okay, so what we noticed that the branches gets wider, so it gets wider. So in other words, we can say that in this case coefficient a is it's less than 1 and more than 0. So in this case, the branches gets wider. What about the second graph, negative 2x squared? So for 1 we have negative 2, it's right there, symmetrically. And for 2 we have negative 8, it's like 1, 2, 3, 4, 5, 6, 7, 8. So this level negative 8, so this is the level negative 2. And all the branches will be, actually they get narrow in this case. So here's how I can drop the graph. Okay, one more time, maybe more precisely. Okay, so that's for parabola with the equation y equals negative 2x squared. So first of all, what we notice? We notice that all the values raised by a factor of 2. So compare 4 with 8, 1 with 2, so 4 with 8 again. And they both, and they also get the negative sign. So that's why all the values actually flip over. Okay, so here's the values that we got here. Okay, and you notice that parabola gets narrow. So it's a horizontal shrink. So gets shrinked or simply narrow. narrower. Okay, I'm not advising you to, I'm not gonna, give an advice to or memorize what about like what's happening with the branches. You can simply test using data set or data table, and you clearly see what will happen. Now you just drop and you understand what's happening with the parabola. So in case, to recap, so in case when a is less, in our case is less than -1, so absolutely a is more than 1, so your parabola gets narrow, but if it's negative, it's simply flipped over, so branches down. So in this case, it's shrinkage. In the case when a value is less than 1 but still positive, your parabola is not flipping, the branches is still in the same direction as for the basic one. However, what you notice is that it gets wider. So that's the general observations, but one more time, I don't recommend to memorize that. Just create the data table, use the coefficient, change the values for y in comparison with the basic one, and see what's happening, okay? That's an idea. So, by the way, that was transformation of enlargement, or how we used to call that, it's scale up or down with a factor, or with a scale factor of a. So this is general factor of a that you can see as the coefficient before basic parabola x squared. Okay, so let's go next. And here is we quick discuss what's happening here. So x squared plus k, what's happening? The parabola is simply shifting upwards or downwards. So this is the vertical translation by k units. So k units is what you add into your basic parabola. So indeed, how you need to interpret this writing is simply you taking basic parabola and you adding k units. So k might be positive. In case k positive, add k units up. In case k negative, k units down. So simply the shape of the parabola, the shape is not changing. Let's pretend that this is your parabola, yellow one, and now you add in k units and they're positive. Let's say you add in 1 unit, x squared plus 1. It means that every single point on the branches will be shifted 1 unit up. In this case, the form or the shape of the parabola is not changing. So as in our case, x squared minus 1 is simply your parabola goes 1 unit down. In case of x squared plus 3, your parabola goes 3 units up. So basically the vertex is changing and every single point is changing, however the shape is not changing. So for example, I drop this for x squared plus 3. It's like this. And I also copy that and say, okay, we've got another one which is shifted by 1 unit down. So that's for another one, okay? So this parabola correspond to, so the bottom one correspond to x squared minus 1, 1 unit down. And this yellow one correspond to here as x squared plus 3, so that's the second one. So actually how you can check, so let's take the vertex, it's right there, the vertex is still the same, it's still on the y-axis. So here you subtracting 1 unit, so that's why the new y value for x squared minus 1 is going to be -1. So that's why you see that the vertex becomes here, so that's the vertex. And this case, this is y coordinate of the vertex. X squared plus 3 is simply you add into the previous value 0, 3 units. So that's why you'll get just 3, and it starts from 3, okay? So that's how you can do. And for every single value, here you subtract, so you'll get 3 and 1 minus 1 is 0. The same you can do here. So it's 0 and 3, because that's still symmetrical one. And here you add in 3, so to the previous value 7 and 4. The same, 7 and 4. So that's why there's significant rise in all values. As you notice in previous case, the shape is changing during the scaling, okay? While here, the shape is not changing. During translations, during the vertical translation, the shape is not changing. That's the key idea, okay? Let's go next. And here we have graph in the form x minus h, which is squared. So h is some constant. So what it means that we're shifting our parabola just simply some units to the right or some units to the left. And what's happening actually, if this is our parabola, we just let me see. Okay, yeah, I catch this. All right. So let's take this basic parabola, and what we're doing, we're shifting h unit to the right horizontally or h units to the left. Okay, that's what's happening. Let's have a look at the bottom case, x squared. Here, x squared plus 2, x plus 2, sorry, squared. So what it means, x plus 2 squared, what it means that we're going to shift every single value for x coordinates, because this is horizontal shift. So y coordinates are staying the same because you're shifting only horizontally. However, x coordinates are changing. So in this case, if you have x plus 2, you will have the shift by 2 units to the left. So we have it here, okay? So that's how parabola will be shifted, okay? So next one, we can also use the same for 1 minus x squared. However, we need to slightly change that. If I write that this is the same as x minus 1 squared, yes, because we need to have this form. Now we clearly see, because that's the same, right? You can even prove if you like. So it's going to be minus, and you swap the signs inside and square it up. And because it's minus squared up will give you always positive. So that's why it's the same as x minus 1 squared. So what are you going to do? In this case, you're shifting your parabola, basic parabola, to the right by 1 unit. So that's how it works, okay? So in this case, this is going to be equation 1 minus x squared. So shift by 1 unit to the right. While here, from the basic one, you have the shift by negative 2 units, so means 2 units to the left. And that means that the vertex becomes negative 2. Now let's go to the coordinates and actually try to prove what actually happened. So you taken simply 0, 0, and you plug instead of 0. So you've got 1, okay? So x plus 2, you plug in 0, and you've got y value is 4, okay? Next one, that's y value, be careful. Next one, so you plug in negative 1, and you'll get 2 squared, so which means 4 here. So if you plug 1 here, you'll get simply 0. And look what happened. So x 0, yes, x 0, and values that were here, now they shifted actually by 1 unit to the right, okay? By 1 unit to the right. So let's take and plug 2. So if we plug 2 instead of x, you'll get 1 minus 2 is minus 1 squared is 1. So that's why actually you see that the next figure is also shifted in comparison with the previous one. So you have shift in y values. I mean, they're not changing, however, they shifted. They correspond to another axis which are 1 unit ahead. So that's why this complete shift by 1 unit to the right. So that's why we have exactly this parabola that was shifted to the right by 1 unit. So that's the proof using the data set. Okay, we can experiment with x plus 2 squared. So we've got 0, we plug here, and we've got 4. Next, we plug 1, we'll get actually 9. Okay, we're not going to do it this way, but we actually calculate here what stays here and here. So minus 1, it's 1, so it's going to be 1. And if we plug negative 2, we'll get 0. As you can see now, this pattern that was originally here, I just circle it quick. So let's take red. So now this pattern that was corresponding to that values now is shifted how much? 2 units to the left. So 4 shifted to here. So that means that was the shift negative 2 units or 2 units to the left. So that's why we proved that every single value for every single point on the basic parabola were shifted by 2 units. Okay, even if you take this point, for example, it was shifted also 2 units to the left. So that what is called horizontal translation. This was horizontal translation, and simply by h units. In this case, generally you understand that if we consider h positive always, so x minus h will tell you that where h is positive, it means that it's h units to the right. Okay, while here y equals x, for example, plus h squared, it's and h still positive, yes, h still positive, so that means it's h units to the left. Okay, so that was also translation, no change in shape, it's only the shift. Here that was shift up or down, and here that was shift to the right or to the left. So that's why in general we can recap using that form. And right now I just solely write what each figure, what each coefficient stays for. So this is the scale or scale factor. This is h, horizontal shift, and finally what we have, k, is a vertical, so k value is the vertical shift. Okay, so that means if we have something like y equals x squared, and now we have this form which actually comprise several transformations, we simply can split by several steps and say that so coefficient before expression where x stays in the brackets and squared, before actually complete squared, is -1, so scale factor is -1, so that means that our parabola is flipped over. Next, 3 minus x we can rewrite as x minus 3 squared, and it means here it's h units. So h units means 3 units. So this is h. I must say that, okay, this is h. It means that it shifted 3 units to the right. So our basic parabola shifted 3 units to the right, and that means this is now the vertex for now, but it also shifted 1 unit down. So this is simply k, and that stays for the vertical shift 1 unit down. So that's why right now the new vertex for our parabola right now, it's right here. So that's the new vertex, and you can even state that the vertex coordinate right now it's 3 and 1. So that's why h stays for x coordinates of the vertex and k stays for y coordinates of the vertex. And now we understand that because we have a scaling, so, and there is no like any figure, like any number different from 1, so a is absolutely 1, so there is no change in shape. However, negative sign means that our parabola is flipped over, so the shape is not changed, however it flipped over. So that's why what we need to say, the following, that if we take this one, yes, here is the basic one. So first we shifted 3 units here, then 1 unit down, and now what we need to do is simply to turn our parabola so that it starts from here. So that's how it can be done graphically. For you guys, you can also check using data table. So if you plug the values, you understand that when x is going to be 3 right now, I just add artificial 3 here. And if you plug here, you'll get -1. So that's the new vertex. So that's the new vertex for our parabola right there. So new vertex will have 3 and -1 new coordinates according to transformations. Okay, so that's how you can describe transformation. It was like, I think, complete explanation for that. And next time you'll have a chance to practice real quick for that. That was explanation. Thank you guys. Happy Valentine's Day. Don't forget to check the channel for A-level class. So that's Zillion's A-level class. So you'll find pretty a lot about trigonometry and other stuff. Don't forget to check also my GCSE level, and actually you'll find A-level stuff as well here. Mechanics, that's what I started from. Also, if you like to get more, get more aware of what you expect to have on entrance exam to Oxford, to Imperial College, you can also check the Oxford MAT, so Mathematical Admission Test 2019. I think you'll find some like really nice explanation for several, I think for the first 6 problems. Yeah, and actually just stay in touch with me, guys. Thank you. Thanks for your support. You're welcome. Peace.